Okay, let's take a look at Explore 2 of gravity. The essential question is going to be, what is Newton's law of universal gravitation? Okay, go ahead and hit pause and take a moment to write down what you know or think. Okay, hopefully you took a moment to write that down. We're going to go and start with Roman numeral 1. Okay. This should be pretty familiar material now. We've been covering this in one way or another over several different chapters. Of course, we can thank Newton for providing this law. We can thank Cavendish for giving us the gravitational constant, 6.67 times 10 to the negative 11 there. So we'll go ahead and write this out again. Okay. The force of gravity was equal to the gravitational constant. We can write it this way: times the mass of object 1 times the mass of object 2 divided by r squared. This is the same thing as putting the g just on top of the numerator there. Okay. Cavendish came up with g being equal to 6.67 times 10 to the negative 11 newtons times meter squared over kilogram squared, okay, which you are familiar with, right? Now, something that is kind of related to this thinking is gravitational fields. So this force of gravity is for calculating the force between objects. So let's just go and write that maybe out here. Use to calculate force between objects. So what if we just want to define an object's gravitational field? Well, that's what this next section is about here. The law of universal gravitation describes the gravitational field of every object. And so you can see here, if I go ahead and expand on this there, they kind of give you a new way of looking at this. They say G of Earth, that's the gravitational field of Earth, is equal to the force of gravity between the objects, taking out, say, the moon, the mass of the moon. If you just want to know the gravitational field of Earth, now you can, if you remember some of your math tricks, pull out your bag of tricks there. We could go ahead and pull out the 1 over the mass of the moon. and multiply that times the force of gravity. And the force of gravity is G times the mass of Earth times the mass of the moon. So we're considering the Earth and the moon right now, divided by the r squared. And then you would know that the mass of the moon would cancel and the mass of here. And so what you'd be left with would be that the gravitational field for Earth is equal to the gravitational constant times the mass of the Earth divided by r squared. Okay. And you could do that, the same thing for the moon as well. Okay. And then they take it just another step forward and they say, well, if you had an object like the moon at a distance r from Earth, it feels a force equal to the moon's mass times Earth's gravitational field. So they kind of just show you how to work it back and forth. So I probably would suggest that you take a look at this paragraph here, just kind of contemplate it. They're not going to give any math problems from here, not yet. The homework problems for this section are really straightforward. They're just using the f of g formula. Okay, so believe it or not, that's it. That was pretty short. You have 4 homework problems that you're going to have to take a look at. So go ahead and make sure you do those. And let's go ahead and just take our line down here. And let's just go and write a summary paragraph. That was pretty short, huh? All right. And we'll talk to you soon.